episode of Life in Overdrive. They just keep coming. No matter how hard we try to close the interdimensional rift that they keep popping out of, a new episode seems to get spat out every week, and there doesn't seem to be any stopping it. So I just keep posting. Hopefully somebody gets some enjoyment out of them, or the interdimensional creatures that exist in the void between universes are at least appeased by the fact that I'm putting them out there. Alright, but seriously, I have an extremely special episode for you guys today. I had a conversation with Alan Stern, a planetary scientist and the principal investigator on the New Horizons mission. That's the probe that flew by Pluto back in 2015. You may remember those crystal clear images that we have of the planet. Oh boy. Dwarf planet. Oblate. Spheroid. It's definitely one of those. I'm so glad to have been able to sit down with someone who is involved in pushing these new space frontiers, because planetary and eventually interstellar exploration are so important to the survival of our species and our understanding of the universe as a whole and where we come from. Now, just a little bit of housekeeping to get out of the way. It is my desire to keep this podcast ad-free indefinitely into the future, but I would also like to improve and expand the podcast in new and interesting ways. Given that the podcast itself is ad-free, the only way that this can happen is through the generous donation of listeners. Now, I'm not going to be holding the podcast for ransom, and I'm certainly not asking you for anything if it would cause you financial duress in any way. But I have started up, as I mentioned on the last episode of the podcast, a Patreon, which is a subscription-based service where you can give monthly any amount that you choose. But it's also kind of like Kickstarter in that it lets us creators make reward tiers. So on mine, for example, if you're a patron at all, then you get to see the bonus background patrons only content. That can be $1 a month. You're in. But then if you hit the $5 mark, you earn the privilege to submit questions ahead of time for guests that are scheduled in advance. And then I will host a Q&A section with those guests during our interview, where I read some of your questions to them and have them answered. Now, I'm also working on a novel called The Sinister Lord of Sparkletown. It's not complete yet, but when it nears completion, I'll add a couple more tiers involving that and my writing. Think signed copies of the books, all those kind of goodies. I just really think that the future of entertainment is tracking in that direction, given the internet, and I think it's a beautiful thing to see other creators who are being supported entirely and directly by their fan base. So if the podcast does grow and change in new and interesting ways, it will be 100% thanks to contributors and viewers such as yourself. So if you get any kind of value out of the podcast and can afford to do so, I humbly ask that you check out the Patreon. That's Patreon/Life in Overdrive. And I ask that you donate whatever you think is reasonable. You'll get some pretty cool kickbacks in exchange. Now, just to provide some context for my conversation with Alan Stern, at the beginning of our conversation, we jump right into the contentious debate over whether or not Pluto is actually a planet. The whole reason this came up in the first place is because when we discovered Pluto, it seemed like it was the only body in the solar system where it was. But as we got better instruments and our technology improved, we started to discover other smaller objects within Pluto's orbit. And Pluto was always kind of an oddball because it's a trans-Neptunian object, which means its orbital path crosses the path of Neptune's. It's also a little strange because it's highly angular. Most of the bodies in the solar system are in a relative disk. As Alan says later, it's more of a donut, but think of it as a disk for the purposes of this explanation. Pluto is highly angular, which means its orbit is tilted and is kind of out of that disk. It's on a weird angle that cuts through the disk. On top of that, we started to find larger bodies within Pluto's orbit as well, including Eris, which is slightly larger than Pluto. I incorrectly identified Pluto as the largest object in the Kuiper belt in our conversation, and I should probably point out that that's not true. Eris is the largest object that we've discovered in the Kuiper belt. It's slightly bigger than Pluto. Now, all of this led the IAU, the International Astronomical Union, to come together and try and define what makes a planet a planet. I'm just going to read off word for word the 3 bullet points in their definition of a planet. 1, it has to be in orbit around the sun. Pluto, check. 2, it has to have sufficient mass to assume hydrostatic equilibrium. That means it has to have enough mass, enough stuff in it, for its gravity to be strong enough to pull it into a sphere shape. Pluto, check. Number 3, it has to have cleared the neighborhood around its orbit. And this is the linchpin that kind of kicked Pluto out of planethood. It's also fair to note that if it weren't for this, Eris would be considered a planet, along with a couple other objects in the Kuiper belt, and Ceres, an object within the asteroid belt, the largest object in the asteroid belt between Mars and Jupiter, would also have to be considered a planet. Part of the argument also includes that there are some moons in the solar system that are larger than Pluto and would also have to be considered planets by that definition. I'm not sure where Alan falls on that particular topic, but my opinion would be that since it's not in orbit around the sun and it is in fact in orbit around a planet, a sun-orbiting object, a moon by definition cannot be a planet. That's just my take on it. I don't want to put words in Alan's mouth. But the point is, if it weren't for this new definition, we would have a substantially larger amount of planets in our solar system. And I think that's pretty good background context for our conversation. It's also worth pointing out, as Alan does later in the conversation, the IAU is a confederation of astronomers. Alan is a planetary scientist, and these are the experts on what planets are and aren't. So I would keep that in mind. I had a lot of fun talking to Alan. I've always been fascinated by space, and I hope you guys love this one as much as I had fun doing it. See you at the end.
20 bucks and a couple ideas. Listen close and I'll play them again. Can I live in this world of sin with the Holy Ghost being my kin? No, 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 no.
I have always had a great interest in science and particularly space, and I've been following the New Horizons mission for a while because I knew already that it was it's not a planet anymore. Well, it never really was, but...
Well, I'm going to disagree with you there, and in fact, most planetary scientists call Pluto and all the dwarf planets, and I would say that we're the experts, not the astronomers who study black holes and galaxies. We can talk about that as much as you like, but that's really a very false impression.
Okay, well, I would love to talk about that, actually. Just real quick, the reason that I got so involved in following the New Horizons project was because I knew that Pluto was the one of the classic 9 solar system bodies that we didn't really know what it looked like. We just had this fuzzy, pale dot of something that was far away. And you see these, when you're at least in elementary school, you see these illustrations in textbooks, and you kind of get the idea that we know what it looks like. And I probably didn't realize until I was, 18, 19, that we actually had never seen an image of the planet before. So when I heard that we were sending a probe, I was extremely interested.
Well, it took a lot of work, but we got one there, and Pluto turned out to be spectacular, didn't it?
Yeah, definitely beat. And like I was assuming in my head it was just going to be another one of those boring pieces of dust and rock that you've seen 100 million pictures of, you know what I mean? And it was not that at all. It was a pleasant surprise. I'm sure that's an understatement for you.
Well, spaceflight's a team sport. New Horizons is a big team. Over 2,500 people worked on New Horizons from the time it was conceived until we got to Pluto. And Pluto just turned out to be, it's a sci-fi planet. I mean, sometimes I tell people, I think the solar system saved the best for last.
Well, and I mean, it seems almost a little poetic that it has a giant planet-sized heart imprinted on the side facing us.
Well, I couldn't believe it when we saw that, and how accurately, how much it really looks like a heart. It's amazing.
It was the first thing that I thought when I saw that picture of it. I was like, holy cow, there is a heart on this planet. But yeah, let's dive into that.
Hey, that's great to hear you call Pluto a planet. You've evolved. You're catching up with the 21st century.
So I mean, I obviously your opinion holds a lot of sway on the matter of what Pluto itself is, since you're studying it so closely. What is it that makes you say that it does fall into the planet class?
Well, I would say that based on two things. The first is just purely scientific. Pluto has all the attributes of things that we call a planet. It's large enough to be rounded by self-gravity. It's a perfect sphere.
Mm-hmm.
It's got active geology, weather, clouds, climate, 5 moons, glaciers. It snows there. It's got the same attributes the Earth does. But I think even more importantly, as a professional planetary scientist, there's several thousand of us in the world. I go to scientific meetings several times per year. And in technical talks and in written papers, all of my colleagues, almost to a person, refer to Pluto as a planet. They refer to many other small objects that astronomers don't think are planets as planets, but we're the experts. I mean, if you had a brain problem, you would go to a neurosurgeon. You wouldn't go to some other kind of doctor.
Mm-hmm.
You shouldn't go to an astronomer for expertise on planets any more than you'd go to me as a planetary scientist for expertise on black holes. And it's kind of a done deal. We just published a paper written by Phil Metzger that shows that no technical paper in the literature uses the astronomer's definition.
Yeah, I would not have figured that. That's surprising.
That's because that definition is based on where things are, not what things are. And nowhere in astronomy, in any kind of space science, do we classify things that way. And biologists don't. They don't care if a given, let's say, a cow is in a herd or by itself. Geologists don't care if a mountain is part of a mountain range or it's isolated. We just don't classify things based on where they are. It's about the object's attributes. And Pluto qualifies on every basis, as do all these other dwarf planets, which totally outnumber all of the giant planets and all of the Earth-like terrestrial planets combined. This is the most dominant class of planet in the universe that we know of, the dwarf planets.
Well, and I guess we don't know because we haven't really directly studied any other Kuiper Belt objects, at least nowhere near to the degree that we have Pluto. But it is my guess that being the largest Kuiper Belt object, that it's probably set apart from most of those in that way. Like, I doubt most of them have rounded themselves due to gravity and mass, and I doubt they have their own weather and stuff like that.
Absolutely correct. In the Kuiper Belt, there are literally billions of things, a few kilometers across, that we call comets. And there are hundreds of thousands of things that are, kind of 100 kilometers across, kind of 60 miles in scale. But there's only a handful, about 10 objects in the Kuiper Belt that are bigger than 1,000 kilometers across. Pluto's 2,500, closer 2,400 kilometers in diameter. And these are the ones that we call dwarf planets.
Mm-hmm.
Because they do round themselves due to self-gravity. And that's really the key. All planets are round for an important reason. The physics makes them round. Little things aren't round because they don't have enough gravity to crush themselves into a sphere. But Earth and Jupiter and Mercury and Pluto all do that. And that's the hallmark of planethood, is when they become round due to self-gravity.
Mm-hmm. I think that's probably the only dividing line that actually makes sense, because there are so many other, like, just for the Pluto example, one of the things they have in the astronomy definition is that it has to clear its neighborhood of debris, which would make Pluto disqualify since it's part of the Kuiper Belt.
That's a false way of doing things. Back in 2006, when the astronomers did that, they did it because they wanted to manage the number of planets to be a small number, which is very anti-scientific. It's basically saying we're going to ignore the data and legislate a way to keep the number of planets small. And the reason they did it was so school kids wouldn't have to memorize the names of more and more planets.
Mm-hmm.
Now, the fact is, there are countless stars and galaxies, and no one worries about that.
Right.
We don't try to manage them to be a small number so we can remember their names. We don't do that with the rivers of the Earth. We don't say that only the 7 or 8 biggest rivers count as rivers and everything else is not a river. It's a dwarf river. We don't say the periodic table can only have 8 elements because no one will ever remember the names of them. It's really an old, quaint 20th century notion because we only knew of 9 planets then, that you could know all their names.
Mm-hmm.
And so then in the 1990s, we started discovering all these dwarf planets and planets around other stars. And we have to discard the notion that you could know all their names. You know, where I live in Boulder, Colorado, it's beautiful. And to the west, there are 4 mountains that you can see from Boulder, from north to south along the Front Range of the Rockies. You know, if you were a Arapaho Indian a few hundred years ago, they were there. And you might think there are only 4 mountains in the world. And you make them very special because there's nothing else like them. But if you ever climbed up on top of one of them, you look out and see a sea of mountains called the Rockies, and you realize I was completely wrong. I was limited in my view because I couldn't see the whole expanse. And then you'd have 2 choices. You could say all these other things are not mountains, or you could just say there's a lot more than I knew about. That's what's happened in planetary science. We've discovered that the universe is littered with planets, more planets than stars, and that our solar system was really good at making planets. And sorry if the Earth is insulted, but the Earth-like planets are not the majority. It's these little dwarf planets that the solar system made the most of.
Mm-hmm. Well, and I mean, I honestly never thought about it that way, but the mountain example is great because, to pilfer a quote from Carl Sagan, there are billions and billions of galaxies with billions and billions of stars, and we know there's more planets than stars. It's just a countless number that it would boggle your mind. You can't even comprehend it. And now you're saying there's more of these dwarf planets even than those planets in the sky. It seems silly to arbitrarily limit it just so that we can remember them when there's, like, you can't remember what's up there anyway.
Well, you know, I remember as a kid, at some point in grade school, we had some lesson about the rivers, and they made us memorize the names of the 8 biggest rivers, you know, the Nile and the Ganges and the Amazon and the Mississippi, etc. But, you know, there's countless rivers on the earth. We didn't have to memorize all of them. We were just told you can look the rest up in a book. You can go to a map anytime you need it. All you need to know is about the really big ones. And I think the solar system will go that way, that kids in the future will be taught there's a crazy number of planets. We're still discovering them. It's awesome that our technology has advanced to this point. You need to know some famous ones like Mars and Venus because they're close to Earth, like Jupiter because it's the biggest one we know of in our solar system, like Pluto because it was the first of all the dwarf planets. But you don't need to know all of them any more than you have to memorize the periodic table or every digit in pi, which is impossible.
Right.
I mean, if we're worried about big numbers, why do we have 50 states? Let's go back to 8.
And I mean, it's not like kids don't manage to memorize 50 states. So, I mean, if there were 50 planets, presumably they could handle that.
Yeah, but I think it's more like the rivers, you know.
Yeah, I agree.
They'll have to learn just the famous ones, and then the rest they can look up on the web.
Right. So, I guess another thing that I wanted to talk about was New Horizons isn't done.
Not by a long shot.
It went to Pluto, but it didn't stay for very long because what a lot of people don't realize about astrophysics is it's incredibly difficult to slow yourself down once you're moving at those speeds. So you guys just kind of went right by Pluto, and now I think you're targeting a Kuiper Belt object that's not Pluto now, if I'm correct.
No, that's right. We're only 54 days away from our next exploration flyby, 1 billion miles beyond Pluto, out in the middle reaches of the Kuiper Belt. And the object that we're flying by has this really cool name, Ultima Thule, which is Latin for beyond the known world.
That seems fitting, seeing as how it's going to be the farthest object from Earth that we've ever sent something to.
Yeah, we're going to set a record. It's going to be awesome. It's on New Year's Eve and New Year's Day when we make that flyby.
So what was it that made you select this particular body? Was it just the angle of approach once you were coming out of Pluto, and it was the most relevant target in range? Like, what made you narrow it down to this specific one?
Well, the spacecraft only has a certain amount of fuel on board, and in order to intercept anything, we have to fire the engines and change course to go get it, to go fly by it. And so there were only a handful of candidates that we could choose from that were within our fuel reach.
Mm-hmm.
And we chose Ultima because it required the least amount of fuel and left the most in the tank for future flybys.
Okay.
So That seemed like a low risk approach to us. And it also scientifically is part of a very important subgroup in the Kuiper Belt with a funny name called the cold classical Kuiper Belt objects. And cold classical doesn't refer to their temperature being cold. It refers to the kind of orbits that they have, which, when you do the simulations in a computer, show that these are bedrock samples of the material that formed small planets out there 4 billion years ago. And so these are the most connected to the origin of the solar system. Mm-hmm. That's scientifically mouthwatering, because we're basically going through a timepiece, something that's been out in this deep freeze near absolute zero for 4 billion years. And who knows we've never been to anything like this. We're going to find out on January 1st and 2nd, when the first images come down, what something like this is like. It could be completely alien.
Well, that's always exciting. You're pushing new frontiers, which is kind of ingrained into us, I think.
That's what NASA does, and we're proud to lead that part of it, in the deep outer solar system for NASA.
It's one of the most important things that our species is doing today, honestly, because this rock's not going to be around forever. I know it's easy to kick that can down the road and not think about it right now, because our sun's going to be here for quite a few lifetimes. But it's also not a problem that gets solved overnight, so it's something that we need to have a slow burn on and be continuously working on if we're ever going to have success in time.
Yeah, absolutely. And, I think, there's only one species of all the species on Earth that are explorers, and we're it. I love my Labradors, but they might be inquisitive about how something smells or tastes, but they're not out there searching and trying to learn about the natural world and the universe around them. Mm-hmm. They're explorers. We always have been, from when we invented boats to sail the seas, to polar expeditions, to climbing Mount Everest. And space exploration is the biggest stage you can imagine for exploration. We're on New Horizons doing the farthest exploration of worlds that has ever been attempted. And it's just like pinch me every day that I get to do this for a living.
I can imagine. What is the end goal for New Horizons? Like, once it's out of fuel, are you just going to do what Voyager wound up doing and just send it straight out of the solar system into interstellar space and see what happens and how long it runs? Or is it going to wind up derelict and orbiting a Kuiper Belt object?
Well, let me go through it in sequence. Immediately ahead of us on New Year's Eve and New Year's Day is the flyby of Ultima Thule. And then, after we fill the flash drives on the spacecraft with all the data, the images and spectra and everything else, it'll take us 20 months, way into the fall of the year 2020, just to ship all that data back. And then we're going to go looking for another flyby target. And we think we have the fuel to do that, but we don't know if the intercept, if the flyby will be in 2021 or 2024 or 2027. We don't leave the Kuiper Belt until 2027, and we're going to have to go find a target and fly to it and do another exploration even further out. Mm-hmm. Then after we leave the Kuiper Belt, the spacecraft will be used like Voyager to fly out into interstellar space beyond the sun's heliosphere, but with much more sophisticated instruments on board than Voyager had to study that phenomena.
Right.
We have enough power to operate the spacecraft well into the 2030s, maybe even further out than that. And so I think New Horizons is going to be the gift that keeps on giving. And, we can do more podcasts with you for future flybys and when we get out into interstellar space. I just think it's cool.
Oh, yeah, absolutely. It's one of the most fascinating things that we're doing today, in my opinion. And I don't mean that to just sit here and kiss your ass. It's really important work. And like I said, I've been interested in space my whole life, and it's just crazy to see the things that we continue to discover every day.
It's really a credit to the people who persisted to get a mission to Pluto and beyond. And it's also a credit, to all those generations of engineers and scientists from the 1950s all the way forward to the 2000s that worked to perfect the art of spaceflight so we could learn how to do something like this, you know?
Mm-hmm. Yeah, I mean it's a slow build. Those original Voyager probes that we sent outside of the solar system are nowhere near as sophisticated as the instruments that we use today. And I mean it's one of those things where it takes so long to get out there that by the time the equipment actually makes it there, it's already been severely outdated because of the rate of technological advancement that we have.
Yeah, we're excited to be a part of it. It's just amazing. You should come to the flyby and see this team of people who've worked so hard to pull this off. You know, sometimes I say it sounds like science fiction what we're doing, but it's not science fiction. This is real in 2018. We're very lucky to be able to do something like this. Very few people on Earth have been able to do similar things, like the first mission to Mars way back in the 60s, or the first mission to, let's say, Jupiter in the 70s, or as we pushed out with Voyager all the way to Neptune in the 80s. And now it's our turn, but even farther.
Well, and it's always been fascinating to me, just the accuracy with which we can send something out over that kind of distance. Like, Pluto is so far from us that the number doesn't even mean any, like it has no inherent meaning in your head. It's like if I say 4 million or 5 million, you don't really have a concept in your head of the difference between the two intuitively. So it's so mind-bogglingly far away and so small compared to the void that it resides in, and we can shoot a rocket from all the way on our tiny pale blue dot and zip it by this tiny little object so far away. How many times closer than the moon? Like, it's just fascinating to me.
Well, let me try and make it more real, because I agree with you. You know, that when you think of millions or billions, it's no one can picture that really in their head. But if you think of the solar system like the street that you grew up on, and let's say the Earth is your house, okay?
Mm-hmm.
And the sun, which is what we call one astronomical unit away, that's 93 million miles. Let's say the sun is one house to your left, okay? And then between somewhere in your yard and the one house to your left, Venus and Mercury orbit.
Mm-hmm.
And then to your right, in the next yard, is Mars. And 4 houses down the street to your right is Jupiter. And 9 houses down the street to your right is Saturn. And so forth and so on. Pluto is 34 houses away. And then Ultima Thule is 44 houses down the street.
Holy cow.
Compared to just going, say, to Mars, which is the next house over, you know, that's just like way out there.
Right. And I mean, Mars is even difficult to get to. Not by today's standards, because we send stuff there all the time. Well, all the time seems gratuitous. But you know what I mean. Mars is right there, and it's not even that easy to get to. And we're talking about something that's 42 houses down the street, as you said. It's just insane to me that the math works out that well that we can get as close as we do.
Well, we can. Let me give you one example. In order to get the flyby of Pluto right, we had to get the timing just right to get all the satellites of the moons of Pluto and everything in the right place so that we could view everything. And when you work that out, we had to arrive after a 9.5-year journey. We had to arrive within 9 minutes, 450 seconds of the time that we set to begin with.
That's insane.
Think about this. I just flew across the country for some meetings. I flew from Denver to Baltimore. And the airline, I just won't say its name, the airline I was on could not get me there anything like within 9 minutes of being on time. Right? But New Horizons arrived exactly 86 seconds off target after 9.5 years.
86 seconds.
Yeah. And we were early. I was proud of that. We're early.
How fast was the craft going on its journey?
Depends on when. The fastest that we traveled was for a period of time around 55,000 miles an hour.
Jeez.
By the time we got to Pluto, the sun's gravity had slowed us down pretty considerably, but we were still going 32,000 miles an hour, now, which itself is unbelievable. That's like literally New York to LA in 4 minutes. And so like the Voyagers and actually 2 other spacecraft from the 70s called Pioneers 10 and 11, we're just headed out into the galaxy. And it's pretty amazing because even once New Horizons is derelict, you know, when it runs out of power from its nuclear power generator and it's the dead Hulk flying through space, there's nothing out there to cause it to wear down or break apart. And billions of years from now, it will still exist. It will not only outlive our civilization, it very well could outlive the Earth. Because when the sun goes red giant in billions of years and expands to swallow the Earth, New Horizons and the Voyagers are still going to be out there.
That's crazy to think that something we've created will last for that long in the universe.
It is. I remember being in the clean room many times when we were building New Horizons and just thinking in awe that human beings can do something this audacious.
Yeah, it almost doesn't seem real.
It is real. That's the best part.
Another thing that's interesting to me, I mean, I assume that the hope is that New Horizons will still be functional enough to send back data when it breaches the edge of the solar system. Is it called the heliosphere? I can't remember off the top of my head.
Yeah.
Voyager didn't really have the instruments that New Horizons does to take readings once it's in interstellar space, provided everything's still working. The thing that's interesting to me is, for example, when you're on Earth, the magnetosphere protects you from the solar wind to an enormous extent, and it's only once you get up in space that you realize all of this stuff's there. I wonder if there's a similar thing that the sun's heliosphere, I wonder if there's like an interstellar wind or something like that, maybe something that we haven't even yet discovered that could shed light on the nature of the universe once we get readings on it.
Well, Kier, actually, there is an interstellar wind, and we have discovered it. And we knew about it before Voyager from telescopic measurements. But now we've learned about it directly by sensing it with the amazing instruments Voyager has. When we get New Horizons out there in the 30s, we'll do even better in understanding that.
Mm-hmm. Now, is that, I mean, we probably don't know to an extent, and that's fine. But do you think that that wind is created as a result of supernova explosions or something like that? Maybe hawking radiation from black holes? Like, I have no idea what it could possibly be, and maybe you don't either, but I'm just wondering.
No, there are many things, you've named a couple, but there are many things that create gas and radiation in space between the stars. That's what we call the interstellar medium. It's a term invented more than 100 years ago. And the sun is flying through the galaxy at this crazy speed of 30 kilometers per second, 20 miles per second.
Whew.
Creates a headwind as we move through all that material.
Mm-hmm.
The heliosphere is a barrier to it. So in here, inside the cocoon of the heliosphere, like where the Earth orbits, or where Saturn and Jupiter orbit, for example, the sun's environment keeps the galactic environment out. It's a three-dimensional spherical volume by the sun, kind of our cocoon.
Okay. And is that created by the sun's magnetosphere?
It is in part created by the sun's magnetosphere, but also by the solar wind, which is the gases that are escaping from the sun.
Right. That's a fair point. I guess the sun is a giant nuclear explosion. That's an oversimplification, obviously, but you know what I mean.
Mm-hmm. I sure do.
So the sun is flying through interstellar space at incredible speed, and the heliosphere is creating a headwind and pushing all of this stuff to the side.
Right. So it's like if you've ever been boating and you see that bow wave that the boat creates that separates the environment near the boat from the farther reaches. So what's happened is Voyager's already gotten outside of that cocoon, both Voyagers now. Mm-hmm. And New Horizons, which was launched, 25 years after Voyager, or a little more, will get there too, probably in the late 2030s.
I would assume that the fact that there's an interstellar medium with all this stuff flying around has implications for future space travel, because I know especially a lot of our electronics are vulnerable to solar radiation. Is the stuff in the interstellar wind, for lack of a better term, is that of a greater magnitude? Is it more dangerous to humans and electronics and stuff like that? Do we not know?
Well, it is definitely lethal to humans for a lot of reasons. It's too cold. There's no air. It's full of radiation. Those are all bad. Any one of those will kill you. So it's like triply lethal.
I just wonder if in order to have any kind of interstellar transport, we would have to have even better radiation shielding, even better to deal with just the environment once you break out of the solar system.
Well, actually, the biggest dangers are dangers caused by the sun. And the sun creates dangers that can kill astronauts if unprotected in a matter of minutes in some cases. And that's why we have to perfect the radiation shields that spacecraft use that carry astronauts. But as you go further and further from the sun, you're safer and safer in that respect. By comparison, being outside the heliosphere is a way safer place to be than to be like going between the Earth and Mars.
Mm-hmm.
Because it's so much closer to the sun, so the effects are so much more intense, the effects of the sun.
Right. No, that makes sense. I mean, I would liken it to being 2 miles from Hiroshima as opposed to 10 miles from Hiroshima. It's essentially the same thing, radiation-wise.
Yeah, what's the question, though?
Fair enough.
I need more coffee.
I think I need another cup also. Another thing that I wanted to touch on, do you, and this isn't specifically New Horizons oriented, but do you lend any credence to the idea that there is yet another major planet in the solar system that we have yet to discover? Because let me tell you real quick where I'm pulling this from. You obviously know that Uranus and Neptune were discovered because of the way that we added up the gravity in the solar system. Their orbits didn't make sense, and the math predicted, well, there's got to be another massive body out here, and then we looked there, and there was a planet. I have heard, though I'm not 100% how reliable it is, that there are similar issues with the orbit of Neptune, and that there is potentially a planet that's like 6 times Earth's mass, extremely beyond the orbit of Neptune.
Let me just spend a minute. There's 2 separate issues here. The first is, are we likely to find large planets farther out that we haven't seen yet? And there's a pretty convincing answer, yes. There's pretty good evidence that the solar system created more giant planets and more Earth and Mars-sized planets.
Mm-hmm.
They're probably farther out. I mean, they're not closer in. We would have found them already. So that, but then there's this separate thing about a very specific prediction of a planet that's been searched for now for about 3 years, which no one has found, and which I think a lot of people are now very skeptical about. But if you take the long view and you say, if we could be having this podcast in the year 2099,
Mm-hmm.
the end of the century, I would be very confident that we will have found not just a lot of dwarf planets, but some very much larger planets further out in our solar system by then with the advance of technology.
Mm-hmm. Is the reason that we have difficulty finding, because another thing people will say is like, we can find all these exoplanets that aren't even in our solar system, and we can't find the things that are in our solar system.
Right. I'll tell you why. The exoplanets are actually easier, which is counterintuitive. They're easier because the way we find them, most of them, is when they pass in front of their star and make it get dimmer. So since the stars are bright enough to easily see and detect those dimmings, it's not so hard to detect exoplanets. But when we try to detect a planet in our solar system, we have to do it a different way. We have to see its reflected light. And every time you go twice as far out, the amount of reflected light coming back to the Earth drops by a factor of 16, 2 to the 4th power. So it turns out that once you get about 3 times as far away as Pluto, we really don't know what's out there because we can't see that. We can't see planets that far because they're too faint.
Right.
Now, we're to get much bigger telescopes. In the 2020s, they're going to be this new generation of extremely large telescopes that can help us push out further. And then I'm sure in the 30s and 40s, even bigger, more sensitive telescopes. And eventually, we'll start finding these guys that are out there. And there's very good reason to believe they are out there.
Mm-hmm.
The dwarf planets of the Kuiper Belt were predicted. It's called the Kuiper Belt because Kuiper predicted this from mathematical arguments in the 1950s. But they didn't have the technology to find it. And they didn't have the technology in the 60s or 70s or 80s either. But in the 90s, the technology had moved to the point where we could start finding things out beyond Pluto. And that's why it was named the Kuiper Belt, because Kuiper's prediction had been confirmed. But it took 40 years. And now we're predicting that there are more large planets farther out. And, you know, it's a game of delayed gratification. You got to wait for the technology to get good enough to see if you're right.
Well, and I mean, the the outer solar system has always been this kind of weird Wild West hodgepodge of things. It doesn't make a lot of sense.
Love it though. It's amazing. It's the Wild West, just like you said.
It really is. I mean, we haven't even talked about the so there's the Kuiper belt, obviously, but out beyond that there is this grouping of bodies called the Oort cloud, which is mostly made up of comets. And in my head I always kind of group them together because it's just like two large groupings rather of small bodies that are just floating around out there. And what is the difference in location, I guess, is number one, between the Kuiper belt and the Oort cloud, and what is the difference ultimately that makes them two separate things?
They're completely separate. And I actually did my PhD dissertation on the Oort cloud, and so I'm very familiar with that. I'm glad you asked. The Oort cloud lies 100 times farther away than the Kuiper belt. Okay, so they both contain comets and small planets, and they probably both contain larger planets at distances we can't yet find them. So they're a very similar collection of things, but the Oort cloud is the much more distant big brother to the Kuiper belt.
Now, the Oort cloud itself, correct me if I'm wrong here, but I think it's referred to as a cloud instead of a third belt in our system because it's more spherical and not on the plane of the disk.
Right, and that's just because it's further out. The sun's gravity is so much weaker that objects can orbit basically anywhere as opposed to being confined like the Kuiper belt is. The Kuiper belt's kind of a fat, donutty thing. It's not really like a sheet with a hole in the middle. It's not really like a phonograph record, kind of a disc. It's more like literally a donut around beyond Neptune's orbit. Mm-hmm. And as you go still farther out, the sun's gravity keeps getting weaker and weaker because you're farther and farther from the source of that gravity. And the orbits can do what we call isotropize, which means that they can have any inclination, and the Oort cloud is spherical as a result.
Now, I wonder, is that because the stuff on the disk was like initially part of the solar system at its inception? For the most part, I mean, the sun's caught stuff since then. And then the Oort cloud is so close to the outside edge of the solar system. Is that maybe just made of the stuff that like the sun's gravity picks up along the way?
The Oort cloud is stuff that was ejected from the region where the giant planets formed, and either thrown out into interstellar space or, in some cases, caught in these very distant orbits from the sun.
Mm-hmm. That's another thing. Since you mentioned things getting hurled around and ejected from the solar system, we tend to think of solar systems as these really stable, almost clockwork-like systems. And over the long haul, they're really not anywhere near as stable as people would think. It just takes a lot longer for differences to happen. Like I remember reading, I forget where I read this, but it's possible that when the sun turns into a red giant and expands, it's possible that the Earth could get ejected into the outer solar system or out of the solar system altogether. It's possible the sun could get so large that it swallows up the Earth entirely. But the thing is, people tend to think of these solar systems as incredibly stable, and it doesn't take a lot to just take an entire planet and fling it into interstellar space, which is amazing to me.
Well, may I make a little correction to that?
Sure, go ahead.
Actually, it's very difficult to do that. and that's not what will happen to the Earth. We're sure of that.
Just a small correction.
Yeah, well, the Earth is most likely to be vaporized when the sun becomes a red giant star. Mm-hmm. And some of the more distant planets that we think are out there, like in the Oort cloud, can be lost to interstellar space then, because the sun will lose a lot of mass and its gravity will be reduced.
Okay, that makes sense.
Yeah.
So, because some of these bodies do drift from the solar system that they're initially attached to, does that mean that there are just things flying through interstellar space beyond the interstellar medium, as it were?
Absolutely. Interstellar space is littered with comets and what are called planetesimals and planets, for that matter. So even though it's not crowded because the volume is so large, there's a very large amount of stuff that's out there. Mm-hmm. And by the way, I hate to say it, but I'm going to be running out of time here in the next couple of minutes.
Oh, that's okay. Just real quick, if you want, explain to people how they can keep tabs on New Horizons and see what happens with this flyby in early 2019.
Oh, man, thanks for asking. Yeah, there is a lot of ways to do it. First, you can just Google NASA New Horizons, and there are Facebook sites, Twitter feeds, Instagram accounts. We have a website. If you just type NASA New Horizons, you'll find our website. NASA has a website separate from the project website. NASA has a television channel called NASA TV that's going to be broadcasting the flyby. There are going to be hundreds of press that are there, and so every kind of media and social media that you could think of is going to be covering it. So I like to say, come along with us. It's been your Christmas in the Kuiper Belt and your New Year's Eve with NASA.
And I mean, I have to echo the sentiment, because it's seriously not every day that we get to photograph a new body in the solar system, especially one so far away. It's new and important stuff, and it's really exciting.
Well, thank you for your interest today. It's been a pleasure and been a lot of fun being on your podcast.
I will admit it, first I found it funny, but this joke's getting old. We spent our summers dancing in the rain, but now this rain's getting cold. Oh, whoa, oh, whoa,
So, that was my interview with Alan Stern. What a conversation. What a guy. I, for one, can't wait to see what we discover when New Horizons does its flyby of Ultima Thule. Again, this is why we look things up before we start our end monologues. This seems to be a trend. I'm going with Ultima Thule because that sounds the best. The plan is to have Alan back on the podcast after that flyby in January so that we can discuss the things that we've learned. Like Alan said in the interview, this is a primordial body that dates back to the formation of the solar system, so the things we've learned from this category could be rather large. I'm excited to see what happens. It could be anything. As far as the podcast is concerned, this is the week of Thanksgiving, so I'm going to be taking a week off. I'm sorry, I know. But we'll be back the following week with yet another interview. The podcast feels like it's up and running again. It feels nice. Keep this brief so you can all get to your Thanksgiving planning. This is Kier signing off. See you in 2 weeks.
on to get on.